Good morning and good afternoon. This is Monica Paolini from Senza Fili. And today we're talking about backhaul assurance. And I have with me Assaji Aluwihare. He's the Director of Strategic Marketing at Viavi Solutions. And this conversation today is part of a report on this topic. Assaji, thanks for being with us today.
Thank you for having me, Monica.
Okay, to get started, can you tell us about what Viavi Solution is doing in this area? You've been in the business for quite some time. So, what is that? What is it you're doing right now?
Yeah, so I mean, Viavi Solutions, we really provide end-to-end visibility solutions for various applications on the network, from really the handset all the way to the core of the network. And one of the pieces of that is our backhaul solutions, and our backhaul solutions really, what they do is they're designed to ensure the quality of the backhaul network throughout the life cycle. So from the time you build that backhaul, you turn it up to monitoring it and optimizing it and then troubleshooting it through the life cycle. So we provide solutions for that whole life cycle.
Yeah, most of the time operators are worried about having enough capacity in the RAN. In the access on the edge, but the backhaul can also be the bottleneck, and so you do need to monitor it. How is that monitoring the backhaul changed over the last 10 years as mobile networks have evolved?
Yeah, that's a great question, right? So initially backhaul was TDM based when we had 2G and 3G networks. When the primary application was voice, with the emergence of 4G, with LTE, which is really IP-based, we saw Ethernet become the backhaul network. What's happened is that Ethernet network is not only carrying 4G now, it's also carrying the 2G and 3G traffic on that network as pseudo-wire networks. In some operators that operate wider networks for, say, business services or residential broadband, you're seeing the Ethernet network actually being shared with those applications as well. So what's happening is the Ethernet network itself is evolving. It's getting more complicated, and the use cases that the operators are seeing, certainly the mobile operators are seeing on the network, are getting more complicated. For example, mobile operators now are seeing many more devices, many different types of devices. As you've heard on the news, I'm sure, you know, when the iPhone was introduced, that created a completely different kind of behavior on the network. You're seeing different new applications, hundreds of new applications being released every day that drive different signaling schemes, different activities on the network. You're seeing small cells coming into play, driving much more complex backhaul and aggregation schemes. What this means is that that network is becoming very complicated. It's not only a question of capacity, but it's a question of complexity, and managing and prioritizing the different types of traffic on that backhaul network becomes very difficult. So that's what the operator's new challenge is, and we're seeing this in the marketplace, where all the mobile operators in the world are really either evolving to have a backhaul management or monitoring strategy, or growing what they already had, adding more functionality, etc. The evolution of VoLTE is another factor that's really a driver here. VoLTE is now bringing in basically conversational voice traffic onto a network that was designed typically to carry data. So you see that as a challenge as well.
And on top of that, the need to monitor backhaul performance is become even more important, because sometimes the backhaul is shared, not just among different applications, but also shared with different providers, with different service providers, or bought from third parties. And so operators are even more, they have to monitor more closely, correct?
Yeah, absolutely. So as they're building out their network to increase their coverage and capacity, what operators are doing is they're putting cells in more and more different places where they didn't traditionally have backhaul access. So they are now leasing different types of backhaul from different third-party operators, and in some cases they're actually sharing backhaul. In where two operators, multiple operators are sharing the backhaul as well, and this really drives additional requirements. We actually have a customer who is using our solution in the specific case to ensure that in a shared backhaul scenario, they're getting the fair share of bandwidth and performance that they are being they're paying for. And in the cases of third-party operators, there are wireline providers that are backhaul providers that are selling connectivity to these mobile operators. In those cases, these mobile operators want to deliver and sell SLAs, including just basic uptime SLAs, but now more and more complex SLAs that guarantee latency, etc. And so in those cases, those operators are using these assurance solutions to be able to characterize that backhaul and provide that data to their customers, the mobile operators. Mm-hmm. We're also finding that the mobile operators themselves, driven by in many cases the voice quality or the service quality that they want to deliver, and in some cases, you know, these operators are being ranked in the press and such based on the quality of their networks. We're finding some of those operators are coming to us to help them ensure the quality of their backhaul, even though they're not running that backhaul. So what they're doing is they're deploying these end-to-end monitoring solutions to ensure the backhaul from the backhaul from the cell site to the core through a third-party network. So what it is the mobile operator is using the assurance solution to ensure performance, even though they're not running that backhaul network. So in that scenario, they'll be monitoring their backhaul, and if they see a problem, they would push the issue to their backhaul provider.
Mm-hmm. So how have your solutions for backhaul assurance evolved through the years to address all these new requirements?
Yeah, that's a great question. So there are many kind of standards-driven processes for managing a backhaul network. The Metro Ethernet Forum drives certain processes. Typically, a backhaul network, it has kind of three phases of its life cycle. There's the activation phase of that network, and then there's the operational phase, which is when the network is running, where you do performance monitoring on that network, and then really a fault finding and troubleshooting phase of managing a network. Each of these are kind of standards-driven activities. In the activation phase, typically, you have the standards such as RFC 2544 and Y 1564 that exist, and then in the performance monitoring phase, the common layer 3 standard is known as TMOP. These are very important methodologies for testing backhaul, and Viavi Solutions absolutely, we have end-to-end solutions that do all of these. But what we have had to do as the network has evolved is actually augment these solutions to meet the needs of this evolving network. As I said, as the network evolves, latency is becoming very critical for VoLTE, conversational voice. The latency from end to end is important, but it's also important to measure the latency in both the uplink and the downlink direction to make sure that the customer experience is managed. Another problem that we're seeing in these networks is microbursts. In TCP networks, you tend to have the clumping of packets that cause bursts for short periods in the network. Typical performance monitoring systems use synthetic traffic based on, so you engineer the testing and the performance based on what you expect the network to be doing. As the network becomes more complicated, you can't engineer the test to monitor this anymore. So what you find is that you have things like microbursts that you can't detect with traditional monitoring schemes. We have developed a solution that we've augmented these traditional methods using our packet portal intelligence visibility device where we can use real live traffic to characterize the performance of the network. We can find microbursts in real live traffic. We can also, where TWAMP, the standard mechanism, can test from end to end, from the cell site to, say, the MSC. Our solution can segment the test and pinpoint where the exact problem is. So if TWAMP finds an issue, you have to go to each of the individual spots in the network and do tests between intermediate points. With our testing scheme, you can immediately pinpoint where the problem is, and that's enabled by our Packet Portal intelligent visibility devices. So we have a solution that's really evolved past where the standards are.
Mm-hmm. and so it's standard compliant, but move beyond in terms of functionality to make sure that you actually get what you need as an operator.
Absolutely.
So now, in terms of, you mentioned the spikiness of the data, and it's clearly a concern in the RAN, but it's also a concern for the backhaul as well, and you need to measure it. But in order to measure it, you have to get away from the average capacity, the average performance, and really you have to go and start looking at real time. What kind of real time? How often do you need to check? What is the granularity that you're looking at here?
Yeah, that's a great question. So if you're measuring throughput in a network, typically, typical systems today use network element data. Network element data measures it on 15-minute or 5-minute cycles at best. If you want to find a microburst, you really need to be measuring at a millisecond kind of level. Our system is able to measure at that tens of hundreds of millisecond level and find microbursts in the network at a resolution where those would be averaged out in a typical network element-based system. Now, performance monitoring and kind of how real-time the data is really does depend on the application. In financial applications, say if you're delivering backhaul to a financial customer, you need to have very high resolution performance monitoring data, which we can provide. Typical performance monitoring cycles are in the order of minutes. That's what we're seeing. So it is application dependent. Finding microbursts has to be in the millisecond rate, but performance data, is typically gathered on the order of minutes.
And now, as you go into more real time, and you have to deal with much more frequent measurements of the network, you tend to have much more data, and so there's complexity, sheer volume. What do you hear operators say, and can you help them use leveraging that information that it's valuable without being overwhelmed by it?
Yeah, absolutely. So Viavi Solutions, we have a wide range of solutions. We have everything from testing the RAN all the way through for signaling testing or mobile assurance through the core to the EPC itself. We have a wide range of solutions, and our vision as the network evolves into this more complex virtualized network is that the operators are going to need near real-time intelligence, not only to provide quality of experience to the customer, so to be able to understand the customer's experience and react to it quickly, but also to feed the systems that are managing this software-driven network. So we are building systems at the backhaul level and across the entire network. So our solutions will gather data from across the network at a high resolution in terms of time, and feed them into a mediation platform that will then normalize and correlate the data as well, and feed these into other systems that can generate customer quality KPIs or feed third-party systems such as policy or orchestration, things like that. So that's the vision we're driving to across all our product lines at Viavi.
Yeah, and the ability to have end-to-end visibility is crucial, because if you see that the backhaul is not performing as it should, the problem might still be somewhere else. So you need to first be able to allocate the source of the problem. So you have to do this on an end-to-end basis, right? Because if you just look at the backhaul, you might be trying to figure out problem.
That's exactly right. So you have to be gathering data from points throughout the network, feeding it into a system that can then in real time correlate the data. So if you see a bad user experience on a certain application, you can then work through the network and the stack to find exactly where that problem is. And those are the types of solutions that we're bringing to market.
Right. And now, in terms of what you're hearing from operators, what are their most compelling needs, the most urgent needs, and do they vary across the globe?
They do vary across the globe. Certainly, you know, some operators are just evolving to 4G, and many are evolving to VoLTE. I mean, I think most operators are now concerned about 4G and VoLTE and the complexity of the data network and performance monitoring. You see that over and over again. Virtualization is a big challenge for many operators. There are a few that are ahead of others, but everybody's thinking about it. How will these assurance solutions not only become virtual solutions so that they can be deployed on x86 devices in a data center, but also how do they evolve, as we discussed, as a real-time intelligence system to feed these virtualized and software-driven networks. So those are our primary issues that we see our operators dealing with right now, pretty much across the globe. I mean, I think there are, everyone sees that coming, you know, they're at different states of the life cycle, but it's evolving to the same problem as you know.
So, clearly latency is very important for voice, but this has always been the case, except that before it was switched and now it's packetized.
Exactly.
How does that change the way you do backhaul assurance in terms, or are there different requirements there in order to make sure that voice works properly?
Yeah, I mean that's exactly. I mean, latency. That's exactly right. Right. So it's packetized. It becomes less predictable right now. So that's why jitter latency loss on a stream specific basis is very important. Quality of service is implemented at different levels for different types of services, and that's why the complexity of the backhaul assurance solution has to be able to handle and monitor the performance of multiple streams and characterize these streams differently, so that the different services get the right amount of priority. And it's a complex situation. As I said, you engineer the network based on what you expect the network to behave or how you expect the network to behave. But when there's so much other complexity in the network, you have to continuously monitor to ensure that that's being that's happening. The other thing is not only as you said, it was switched, but now it's becoming more meshy too. So the paths that this voice is taking, etc., become more complex, and you need to monitor and track that as well. Right?
Yeah, and another dimension that is changing is with the introduction of HetNets, where you have very different types of RAN elements. So you might have a macro, you might have a small cell or microcell, indoor, outdoor, DAS, you name it. Now, what this come is also with different types of backhaul.
Right.
So the operators, I would imagine, typically have to deal with more forms of backhaul. So does your solution work across all of them in the same way? Are there differences independent? Wireless, wireline, different types?
Yeah, I mean, so we don't have a microwave-based kind of system. However, our solutions do take into account the complexity of the backhaul, the HetNet and the overlay networks, the complexity of the small cells, etc. All of them they drive more complex aggregation schemes on the backhaul network, right? So you see this hub and spoke architectures, things like that. We take all of that into account, and with the use of our packet portal IV devices, again, if you can deploy them at each of these aggregation points, we can build a view of the network performance in a unique way that is different than typical systems that are actively based on sending packets end to end two devices. So yeah, it's the complex aggregation schemes, the complex backhaul, the differences in backhaul that we drive that way.
Right. And what about virtualization? How is that going to have a major impact on the way you look at you monitor a backhaul?
Absolutely. I mean, as I said again, virtualization. Again, traditional backhaul is based on backhaul monitoring is based on some active testing where you send packets over the network, etc. All of that has to change. We have to evolve that to virtualize how you do that. But not only that, but again, feeding systems that drive real-time management of a software-driven network, such as a policy system or an orchestration system, it becomes critical. So a backhaul monitoring system will have to get information in more real time. Back to your initial question about how real time is real time, you have to get that data and feed those virtualized systems to drive those software networks.
Mm-hmm. Right. So this is going to be, as we move forward, there is more virtualization. Operators need to be more real time than they currently are, and so it's going to be a continuous trend to capture performance at the lower granularity in terms of time.
Right. I mean, more meshy clouds interacting with each other. They're going to have to know how the performance is happening, not only end to end through those clouds, but at various interaction points inside those clouds as well. Right.
Yeah. So what's going to happen over the next few years? What is it you guys are going to be focusing on in terms of innovation and new solutions in this?
Yeah. I mean, so again, our big focus at Viavi Solutions is that end-to-end visibility, right? So at every point in the network, throughout the network, from the handset all the way to the core feeding systems. On the backhaul side, our focus areas is really bringing in more innovative performance monitoring schemes that can deal with real-time data and the virtualization point. Virtualization is a very key focus for us in terms of evolving our solutions, not only to virtualize, but to deal with the constructs of a virtualized network as well.
Yeah, well, because a virtualized network is one where things change all the time because the physical, the equipment changes to support the same function. So you have much more inherent dynamic.
That's exactly right. So you can't instrument a virtualized network the way you could in a traditional network where you could monitor or test at two different points. And you have to evolve your solutions now to be able to dynamically monitor it across the mesh and understand path changes, things like that, very quickly. Yeah.
And I guess that really changes the sort of the traditional split between test and monitoring, because you're basically testing and monitoring at the same time continuously, because there is no such a thing as the initial test and then you are done with it.
This is a perfect point. I mean, it is a completely different process change. There is a, let's be realistic, there's still a physical instantiation of the network, right? So there is a test phase that you have to do when that physical network is built out. But then after that, the network is truly dynamically changing. So there is no delineation with a testing phase and a monitoring phase, exactly as you said. As the network changes dynamically, we have to dynamically ensure that maybe the paths the paths are verified as they're built, but then monitor them as you go on. So fully as the orchestrator changes the path or such, we have to test that everything is done appropriately there, and then monitor that path potentially for a very short time before it switches again, right? So.
Yeah, absolutely. Well, Assaji, thanks a lot for your time today and sharing your insights with us.
Thank you very much.
So our conversation today was part of a white paper report on backhaul assurance, and you can read it and download it from our website at Senza Fili. Thank you very much for listening to us.